Hello. In this activity, you're going to draw a model to show me selective permeability. So, once again, I have this in your class notebook because you'll need to be doing a drawing. You can do this in Word if you have that capability and draw on that also. And I'll give you hints on both of that. So let's go to our class notebook. And once again, in your class notebook, you'll go underneath your name and then click on A24. After you click on assignments, so it's your name, assignments, A24, and A7 is selective permeability. So you'll need to annotate this. So you go up to your draw. And if this doesn't come open, it means that you're not underneath your name. You're underneath the content library and you cannot annotate it. So make sure you're under your name, assignments A24. So first off, you'll probably be drawing this time. So you can click on your pen and you can use different lengths of lines. And then you'll be able to pick a color, and you have a color pad here also. And you'll be able to draw things. All right. So again, I do not expect the best art on these drawings, but I do expect something. You can also put in shapes, but you do not have a shapes tab here. So it's probably easier just to draw things if you need to, instead of putting in shapes, because I do not want you to take a image from a picture on selective permeability and just paste it. I want you to actually draw it so that I can know that you have this concept in your head. Once you've finished your drawing, then you need to add a caption. So to add a caption, you would go to your tab that has your text box. You'd enter that off the screen. You can enter it up here, and you'll pull it all the way down, and you'll be able to type in your caption. And your caption will tell me what your drawing shows. So it'll probably be at least 3 to 4 sentences in length. Okay, so I've made a video that explains the difference between, or explains what selective permeability is. And you'll be watching 2 videos. One of them is sort of blurry, the other one is much better. And then interspersed in that, I will give you ideas on what you can draw here. Let's get started on this.
This is you, and this is a robber. We protect ourselves at night from robbers by building a house with walls. We use these walls as a form of protection from the outside world. You probably wouldn't let a robber into your house. But what would you do if your mother was at the door with a basket of cookies? You would probably let her into your house, at least to take the cookies and eat them. The cell has a similar protection known as the cell membrane. Just like you probably wouldn't let a robber into your house, but you probably would let your mother into the house, so also a cell membrane lets some things in, but not others. When the cell does this, it is known as selective permeability. The word selective means not everyone gets in, just like some colleges like Harvard are very hard to get into. The word permeability comes from the word permere, which means to pass. Together, the words mean to selectively pass. Just to repeat, the cell membrane selects certain things to go through, just like a college selects certain students but not others. Because let's face it, just like in relationships, the cell knows what it wants.
So now you have at least one idea about how to draw a model of a selectively permeable membrane, a house. Another one we gave earlier was a net, and it is selectively permeable. Small things can go through, but big things can't. So that's selectively permeable. So now you're going to watch one more video on YouTube, kind of going over what selective permeability means again, and show you some ion transport channels, some protein ones, and then I'll give one more idea for modeling selective permeability.
A semi-permeable membrane, also called a selectively permeable membrane, is a membrane that allows certain molecules or ions to pass through it, while blocking others. One example of a semi-permeable membrane is a phospholipid bilayer, a group of phospholipids consisting of a phosphate head and 2 fatty acid tails, arranged into a double layer, with the hydrophilic phosphate heads exposed to the water content outside and within the cell, and the hydrophobic tails hidden on the inside. In general, small, non-charged molecules such as oxygen or carbon dioxide can freely cross the membrane without an input of energy. They're able to slip between the heads of the phospholipids and pass through the hydrophobic tails through a process known as diffusion. These molecules are able to move down their concentration gradient as they move from an area of high concentration to an area of lower concentration. In contrast, ions and polar molecules have difficulty crossing a membrane. To move as quickly as is necessary, they are often assisted across the plasma membrane by carrier proteins. The proteins that conduct this form of transfer are often called pumps because they use energy to force molecules or ions to move from an area of lower concentration to an area of higher concentration. This is commonly referred to as up or against the concentration gradient.
So this is my final idea on hints for selective permeability. A bike crossing, which has poles that allows bikes to go through or walkers to go through, but not bigger things. So again, you have to draw this. You can't just post something. So you could again have something like poles. Some things cannot go through. Some things can go through, depending on their shape. So that's selective permeability. It's just something that is allowing some things to pass through and other things not to pass through. And sometimes there was channels, possibly a tunnel or something that could help allow bigger things to pass through if we needed to. If you have any additional questions, please talk to your science teacher. Have a nice day.